Okay, let's give you guys some more practice. So similar to the previous video, remember that if you drop a cannonball over the top of a building, your acceleration time graph will look like this, your velocity time graph will look like this, and your displacement time graph will look like this. And remember that if you differentiate the velocity time graph, you will get the acceleration. And then when given a displacement time graph, if you differentiate the displacement time graph, it will give you the velocity. Okay, so starting with this graph, if you differentiate this, it will give you velocity time. If you differentiate velocity time, it will give you acceleration time. Okay, so bear that in mind. So now I'm going to give you the displacement, meaning that I'm giving you in effect this graph here. Okay, so inside your mind, so in this video, I'm going to give you the displacement. So inside your mind, remember, differentiate it, you get velocity. Differentiate it again, you get acceleration. Okay, so anyway, the displacement is given by this. So inside your mind, you've got to try and sketch this graph. When t is small, it will want to do this. So you can think of this as being a positive quadratic. So inside your mind, you can sketch something like this. A positive quadratic. But when t is big, it wants to do a negative cubic. So remember, a positive cubic looks like this. A negative cubic would look like this. Something like this. Okay. So eventually, it will well, when t is big, it wants to do this part and this part here. So hang on, it wants to do something like this. Okay. But then it's only valid when it's big. So we're gonna guess it to be. It wants to do something like this when it's big, but it's only valid when it's big. So it wants. Well, if you don't understand what I'm talking about, then you could have watched this section on sketching complicated graphs. So now we're gonna guess it to look something like this. Okay, and then it will eventually uh, switch direction. Yeah, so your graph will look something like this. So inside your mind, you should be able to visualize this curve here. Okay. So anyway, the displacement graph will look like this. Okay. And if you get a graph plotter and plot it out, it will look like this. Okay. So yeah. So when x is when t is small, it wants to do this this positive quadratic here. And when t is big, it wants to do a negative cubic. So here, negative cubic. Here, negative cubic. Here. Hang on. Negative cubic here. So now, yeah, so you would guess it to look like this. Well, anyway, okay, so now this is a displacement. You're given a displacement. You can imagine this as being the displacement of a car traveling from A to B. Okay, so this here you can imagine it as being time. This one here, the y-axis, you can imagine it as being miles or whatever miles mean, or kilometers or whatever. Just 40. So this up here represents distance, or in this case displacement. Okay, so we are not interested in the time being negative because we can't travel back in time. So ignore time being negative. So you're given a displacement. You're given displacement as being this here. So you can imagine this as being a car starting at A, traveling to B, and then so the time. So you can imagine this as being hours here. T being hours. So the car traveling from A to B. But by the time it gets here, yeah. So this is time going along here. So roughly it takes about 3 hours and a bit to get to B. And then once the car got to B, then it would turn backwards and then don't forget on the way back. So from here to here, so this bit here is B. Okay, and then notice that to get from A to B here is taken it has taken about 3 hours and a bit, but then on the way back it has only taken this much time to get back. So what's happening is that this car it's slow to get to B, but then on the way back it's pretty fast. Okay. Yeah. Well, you can imagine it as so. This is your displacement time graph. So you can imagine it as a car traveling from A to B. The question is, calculate precisely the distance between A and B. Okay. So somehow you've got to interpret what you've been given, which in effect this is all that you're given here. But then you can imagine it as being a car traveling from A to B and then backwards here. So by the time it gets back to here, the displacement will be 0, and that shows up in the displacement time graph. Because by the time it gets back here, you can see the displacement is 0. So when time equals 0, the displacement is 0. By the time it gets to here, the displacement is 0. So that means, yeah, it's gone back here, so the displacement is 0. Well, anyway, calculate precisely the distance between A and B, and where will the car be when the acceleration is 0? So somewhere along the journey here, the acceleration is 0. Okay, but by the way, the velocity is 0 at B, but that doesn't mean the acceleration is 0 at B. So be careful. Okay. So question 2 is where will the car be? Will it be 30 miles away when the acceleration is 0? Where along the journey will it be when the acceleration is 0? Okay. So press pause and have a go. Okay, so to do this here, differentiate it. So you've been given the displacement here. If you differentiate it once, this here will be your velocity, and then if you differentiate it again, then this here will be your acceleration. Okay, so looking at this here, this is the displacement. And notice that when it gets to B, the velocity, so this here is your velocity. The blue line here is your velocity. This here is your velocity. You see, by the time it gets to B, then the velocity is 0. But that doesn't mean the acceleration is 0. Okay, so, well, anyway, the question was, hang on, what was the question? Calculate precisely the distance between A and B. Well, if you look at this here, you've got to learn how to interpret this graph. The distance between A and B is actually given by this here, but we need to find out precisely what this point here is. Well, at this point here, the velocity is 0. So differentiate it once. So differentiate it once. That will give you the velocity. So find out when the velocity is 0. So it's us doing this. You see this. S prime of t is the velocity here. Find out when that is 0. So set the velocity. So this is actually the velocity. Okay. Set the velocity to be 0, and then find out when t equals 0, and blah 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 here. Add t squared to both sides. That will give you this, and then divide both sides by t. Be careful when you make this move here. When you divide both sides by t, just make sure that t is not 0. So keep that in mind. So you divide, so when you're here, divide both sides by t. That will give you this. And then to get t on its own, divide both sides by 6. So the time when the velocity is 0 is given by this. Okay. Now going back to your displacement, this was our displacement equation here. So now we can just put this into the into here, because if you look at this here, hang on. So the distance between A and B is given by this point here, but we need to know precisely where this point is. You see, so at this point here, the velocity will be 0. So in effect, we just calculated when the velocity will be 0. You see, at this point here, t equals, what was it? T equals 20 over 6. So going back here, the time when the velocity is 0 is t equals 20 over 6. Now that we've got the time, we can actually put 20 over 6 into our displacement, and then we can actually find out. So we know the velocity here. So we know the time when the velocity is 0. So we can put this into this equation here, and then that will allow us to jump straight to here. That will allow us to jump straight to here. So that will then give us this value here. But anyway, let's go back to here. So we found out that the velocity is 0 when t equals 20 over 6. So let's just put it into here. So we're going to put this into here and then into here. So that will give us this. And now it's just a matter of tidying it up. Okay. So so blah blah blah, tidy it up, and then it will give us this answer here. So the distance between A and B is given by this. Okay, and now to find out now we've got to find out when. Hang on. Now we've got to find out. Hang on. Now we've got to find out when where along the journey will the acceleration be 0. Okay, so given this here, differentiate it twice. Hang on. Differentiate it twice. That would then give us the acceleration equation, and then find out when this will be 0. Okay, so hang on. So we've done the distance between A and B given by this, and now so we differentiate it twice. That will give us this here. So this here represents the acceleration. So now when will the acceleration be 0? So set it to 0, and then add 12t to both sides. That will then give you this, and then divide both sides by 12, and then tidy it up. It will give you this. Okay, so this is a time when the acceleration will be 0. So let's so remember that the displacement time graph is given by this here. Okay, and we just found out the time when the acceleration is 0. So put this into the displacement equation here, and that would tell us precisely where the car will be when the acceleration is 0. So blah 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 here. Okay, and then so this is the distance. This is the displacement when the acceleration is 0. Okay, because here we hang on. So here this is the equation for the acceleration. So we just found the time when the acceleration will be 0. So we've only got the time when the acceleration is 0. So we've got to put the time into the displacement in order to find out where the car will be when the acceleration is 0. So you put it into here and then follow it through. Okay, follow it through, and then this will then give us the displacement when the car will be, when the acceleration of the car will be 0. Okay, so this here is the displacement, and so it's 500 over 27. Hang on. So it's 500 over 27. Hang on. 500 over 27. So if you look at this graph here, you see at this point here, that's when the acceleration is 0, and we found this time here, and then we put it into the displacement. That would then take us to somewhere here, which is I don't know. Hang on. Well, that would then take us to somewhere here, and somewhere here happens to be, what was it, 200 over 27, something like that. Okay. So yeah. So once you've got your time when the acceleration is 0, then put it into this equation here. That will then take you straight to here. Okay.